Enthusiastic? That's good. Well, hello there. Hello. We're not quite going to start just yet. We're going to try to start soon though.
Do I run? Just coming in at the end of the conversation. Oh, no. I don't like running.
I'm going to push him out.
When Pernod and Charles were so we did a go-kart against last time.
Who's asking a question about FSI? That was you? Yeah.
As what? A Linux client, is that what you're saying? That's good. Thank you very much, by the way.
Oh yeah, hey, thank you for having us. I appreciate
problem.
it. I hope some of it was education.
Yeah, it was great.
I think it's more fun to do it than it is to talk about it.
Yeah, I think, but it's always interesting to hear about it.
Yeah,
So.
yeah. Cool. God, you're so bad.
I can swim. You got to hang out.
Really nice to throw a really lightweight distro on that.
Was that?
Throw a really lightweight Linux distro on that and just resolve half the problems.
Yo, I've for a long time wanted to put Alpine Linux on a box, like a legit Alpine install. Like Alpine's the distro that's used for Docker containers usually. So it's super lightweight. It's like a few megabytes. And like,
Yeah, that's really lightweight.
it doesn't come with anything, like at all.
Yeah.
It's perfect.
Linux is another fun one. It's like really,
Yeah.
really lightweight. I think just like the webcam's not
All right, just kick us out.
No, I didn't want to. All right.
Yeah, well, we'll go to the
Yeah, you guys can. Thank you very much for coming. Alrighty. Yeah, get the fuck out. All right. So, just kidding. I'm kidding. I'm kidding. I'm kidding. We got 15 minutes here. I think we can do it. We're going to talk about Redteam blockchain, the decentralized C2 network. We have a question and we haven't started.
Is it possible to put more buzzwords on this slide?
Yes, there's no machine learning on the slide yet, but we'll get there. All right. Oh yeah, so here I am. I'm Nick. Thank you. Cool. All right. So first, we're going to go over what I would call the naive topology. This is like, oh, I'm just running I'm in a competition here, and so like there's a blue team, I guess, and I guess there's like a red team somewhere, and oh. And we're back. So there's like a red team and a blue team thing going on, and like I guess red team has like beacons or something, and I guess like they're also like lodging in commands or something, and it's like, okay, that's fine, but like what happens if blue team's like, huh, what if I don't let red team do that? So then we have what I'll call the real topology. So like if blue team becomes like more defensive in their apparatus. So again, we have a blue team and we have a red team, standard thing. And red team's like, oh, we got cool beacons. But blue team's like, no. Gone. And then it's like, red team's like, no, it's okay. It's okay. We have a way to like push in some commands over there, right? What if that's gone? And it's like, no, it's fine. We have some last resort custom exploits that we wrote, sad react first, that we wrote for this competition. But what if blue team says no? All right? So like we're dealing with, oh no, red team is completely crossed out from the blue team network. How do we keep going if we can't even talk to them? And that's what this is about. So for example, so I'm going to list some things that you might be thinking because I was like, oh, there's beacons and commands and stuff. But like, what is this custom exploit giant doohickey that you just slapped on here? So like some things, come on. Like that's like our advanced like persistent mechanisms, so to speak. So like that could be like rootkit, bootkits. You've heard a lot of presentations on those. Some web shells, basic bind shells, some application backdoors, yada, yada, yada. But the premise of this presentation is like, if all of those are gone and all of your basic beaconing and all that shit is gone, what do you do as a red team? And without further ado, I introduce the Redteam blockchain. And it's glorious. So let's just go over high level what a blockchain is. And we're going to be the best type of correct, not quite factually correct. So we have a meme. Yes, it's a meme. Is it kind of like a distributed linked list? It's kind of like that, but not at all at the same time. Is it a cryptocurrency? I'm going to say no. Okay, so it is definitely separate from a cryptocurrency. That's just the only thing that has a practical use case for it. Moving on. So then there's features. So these are things that are typically part of the blockchain. I'll talk about how they interact in a second. But you have things like transactions, and those are inside things called blocks. And then you have like this decentralized, consensus-oriented like way that people go about deciding what is the blockchain at that moment, or the ledger. Typically, there's something called proof of work or stake. And again, I think I'm going to talk about that in a minute. And then like all of this is, the ledger itself is housed publicly, so anyone that has access to the blockchain network can see the history of all of that. So let's talk about building said blockchain. So each block in the chain, because that's all the blockchain is a chain of blocks, will contain different transactions. And this is why it's typically looked at for like a cryptocurrency, because these could be transactions between different people with some type of coin. But these blocks also contain other things. Typically, as I said, it was a chain. One block will point to the previous block. It's a hash pointer, but don't get bogged down in the details. And it's also going to contain a bunch of other awesome little tidbits of metadata. It's going to have the hash of the block itself for integrity. It's going to have timestamps, so that way you can say like this block was published at this time. It's going to have a block ID for like easy lookup for like in the blockchain itself. You're going to have a nonce. That has to do with proof of work typically. And then you're going to have the versions, so that way like if there's some weird forking going on, which I'm not going to get into, but if sometimes the blockchain can bifurcate, versioning is useful. So how the chain works is that you have these blocks, which again, they contain transactions, a collection of transactions, and then a bunch of metadata. They're pointing to the previous block, and through the awesome magic that is cryptography, you're guaranteed that there is this integrity throughout the process, and no one could inject the block into the chain. It's strictly linear. It's one block points to another block points to another block, unless there is a fork. We're not talking about that. That's just a trigger word. And this blockchain is housed across all nodes in the network, and it's the same chain, same order, the same amount, because we're only talking about a network with full nodes, so they only have the full blockchain. And this is just kind of a fun tidbit, although not necessary for our implementation. The transactions are actually stored in what's called a Merkle tree, which is a really fancy hash tree. And this is specifically how blockchain does it. There's some differences of opinions on other stuff. Boop. All right, so then we got through that. We struggled through it. We made it through. We're wondering, where is the cyber? And I know it's chanted from the rooftops. People are wondering. So what if instead of transactions for a currency, we put actions that a box wants to perform on the network, or wants an action to be performed? So like, what if it was turn off service? So that was an action, and like if that got published to the blockchain, then everyone that had then added that block to their blockchain will then shut down whatever service is on their box. And then what if, yeah, so like each box will perform a proof of work, which is basically sleep for our case, because we don't actually need proof of work, to figure out which action gets selected. So every single box will want a certain action to be done, and then they're all going to be fighting, quote unquote, to decide which action gets run across all the boxes. I'll show a diagram in a minute. It's a little confusing. Like I said, as soon as you receive a new block, you run the action, then you attach it to your blockchain, and you start all over again trying to win the race. This is great because it can work also if there is still a connection from the C2 into the network, because you can just say, hey, I want you to perform this action, and then all the nodes will pick up that action as another transaction, and then they'll mine it into the blockchain, and you're Gucci gang. In addition, this doesn't just need to be like command and control type environment. You could actually put other payloads and files onto this blockchain, so it can work as a distributed CDN network for Redteam. So we can literally use blue team boxes to house payloads to wreck them. So let's go with fancy diagrams. So here we have, whoever's messaging me, we have the blue team network, like we saw before. Each of them are trying to, or they're sleeping technically, or they're trying to do their proof of work. And they have amazing firewall rules, so we can't touch them at all. So eventually, one of these boxes will mine successfully, or wake up from their random sleep. And they will have an action that they want to get run on all the other boxes. They send that action to all of the other boxes in the network. Like that, it flows through. It's a peer-to-peer type system. All of the boxes will then run said action or actions. And we're back. We'll run said actions. And then they'll go back to their churning. And this process will repeat it again and again. And from a blue team's perspective, just random red team activities are going to be happening. And they're going to be thinking that we still have access inside their network. When we don't, it's just that they are red teaming themselves. So here's an example. Oh dear. Yeah. Here's an example of if the firewall rules aren't there and we still want to use this system as a red team tool. So here, as you can see the difference, there's not amazing firewall rules, unfortunately. Our C2 just pushes out an action that they want to be performed to all of the nodes in the chain. It doesn't need to be broadcast like it is here. It could just be multicast or unicast, and then it's spread through the peer-to-peer network. I don't know why I decided to do it like this. It actually looks worse, but whatever. And then eventually, someone will mine it, and then their action and the actions that were sent from the C2 can then be run and then sent through the peer-to-peer network. And then we go back to our default state, waiting on for the next movement. And we can adjust this like mining period to however we wish, except it needs to be set up at some point while the C2 is able to communicate. So this could be every 5 minutes, this could be every 10 minutes, this could be every minute. It all depends on how much we want the proof of work to last. We have a question.
How do you perform actions that require a certain order?
What do you mean?
What if one of my blockchain boxes
Yep.
gets a command and the other one gets the other command? Can I execute them both?
Oh, so you're talking about what would be analogous to a not forced fork in the chain. So like you're saying if two boxes mine and they both come up at the same time and they broadcast their new block. So like that right here we have one person mine successful and they send their action, but you're saying what if two did?
Well, what if like I have access to a box
Yep.
and pull my command down?
Okay.
And, it's mine or whatever. And someone flushes their IP table by accident. A new box pops up, but I've already queued a new action. Sent a new action.
So
Which one box is it?
you don't control which box is going to mine successfully.
How did they get the action initially?
So that has to do with pre-configuration. So pre-configuration, you're going to bake into these nodes either a single action that each box wants to get run across the network, or a more advanced option would be you define it over a probability distribution. So you say like, there's a 50% chance that when this mines, it's going to do this action. There's going to be a 25% chance it does this action, 25% chance it does this other action. So there's a lot of like variation within it. That answer your question? All right.
How are you planning on hiding the CPU usage caused by
Yeah, so that's why we're doing sleep instead of proof of work. It's not just to hide it, but also because we don't want to break an ESXi box. So if we were just constantly using 99% of the CPU, I don't think Blue Team would appreciate that. And it's also not conducive to a learning atmosphere, which at the end of the day is the purpose of competitions.
I don't think black team would appreciate it either.
No, yeah, black/white team would probably cry if their boxes just started running out of like CPU time, and yeah. And scoring would be yikes. Kind of. So, no. Because we actually moved transactions out of like the case here. So like I guess we could. So we're gonna define some type of secondary mechanism. So like we're probably going to do something kind of like smart contracts to distinguish the difference between this action and this action, because they're distinctly different actions, and this action. Like they're all different. Well, actually that's not an action. But like the idea that like the C2 can just be like, here's more actions, and as opposed to like just a box saying like, here's my block. Like those are two distinctly different things, right? Because remember, actions inside block. So we're going to have to define some things. We could probably define some interest. We're also going to have to define another action for like, here's something we want to be distributed on the CDN network. So it's going to be a fun, but a little bit, this is not, well, yeah. What? Yeah, I'm going to write it tonight, don't worry. Any other questions? Everyone like the memes? We got a question over there?
I just wanted to comment. I thought this is interesting because today's Sam's like Storm Center podcast had an interview on exactly this.
Really?
Yeah.
All righty. Hashtag ahead. So I had like thought of this like a few months ago, and I hadn't clicked in my head how to actually end up doing this until during covert communications on Monday or Wednesday. And I was like, oh, I could do it like that. And then I made this presentation, and now we're here. Cool. There's not a question slide, I think. Oh, there is. So, any last other questions? Or are we? I think we made it in the time schedule, so that's always good. All right. Cool. So, thank you all for coming.